We think of ourselves as the masters of the planet, but for millions of years, the human experience was defined by a single, desperate task: trying not to be eaten. On the ancient savannah, we were the prey. The reality of that daily terror surfaced on November 4th, 1960. A 20-year-old named Jonathan Leakey was excavating in the heat of Tanzania's Olduvai Gorge when he spotted something protruding from the sediment. Working alongside his scientist parents, Louis and Mary Leakey, Jonathan recovered a lower jaw fragment containing 13 teeth. Further digging in the immediate area revealed skull fragments and 21 pieces of hand and finger bones. Laboratory analysis revealed a striking biological detail: the wisdom teeth had not yet erupted. Further evidence from the wrist bones showed that the growth plates had not yet transformed into solid bone. This individual died at roughly 12 years of age. This was Homo habilis, the handyman. Despite its youth, this creature possessed a brain capacity of 600 cubic centimeters, far larger than a chimpanzee's. Its hands were also uniquely adapted, allowing it to touch its thumb to its other fingers to craft complex stone tools. We usually associate tool-making and high intelligence with dominance, but here was a creature capable of advanced motor skills and social coordination, dead in the dirt before its 13th birthday. By the early 2000s, dozens of similar remains had been collected. Physical anthropologist Laura Monica Martinez analyzed 116 permanent teeth from 20 different Homo habilis individuals to determine if early death was a species-wide pattern. This diagram shows how dental erosion acts as a biological clock. As a creature chews, the white enamel wears down, exposing the internal dentin. By measuring the specific wear rate of these fossils under a microscope, scientists can calculate exactly how many years an individual was alive. This visualization plots the results of that study. The average age at death for these 20 samples was a mere 12.8 years. The vast majority of the population died between ages 10 and 14. Only one specimen survived to 25, and none reached age 30. These numbers actually understate the danger. This data only includes individuals who survived long enough to grow permanent teeth. Infant and toddler skeletons were excluded. If we factor in the missing children, the average life expectancy for the entire species likely drops into the single digits. Surviving into the teenage years was a rare achievement. In this era, predators systematically removed the majority of our ancestors from the landscape before they reached maturity. This cycle of death was driven by a massive climate shift. As the earth cooled, rainfall became scarce, and Africa's lush forests transformed into dry, open grasslands. Our ancestors were forced out of the trees and into a landscape with almost no cover. This anatomical comparison shows why the ground was a trap. Unlike a modern human's spring arch, Homo habilis had flat feet. They couldn't run long distances. Their shoulder blades and curved finger bones remained adapted for climbing. They were caught between two worlds. This left them with a top speed of only 20 kilometers per hour. In a landscape filled with predators, they were too slow to escape on the plains and too clumsy to retreat quickly into the trees. Evolution is rarely a clean progression. Homo habilis was a transitional species, stranded in an environment it was biologically unequipped to handle. The grasslands they inhabited were packed with hyper-specialized killers. Within any 10-kilometer radius, dozens of apex predators shared the same territory as these slow-moving hominins. Giant Pleistocene hyenas were common. They were much larger and more aggressive than today's species, hunting in disciplined packs. Their jaws were powerful enough to crush the femur of a rhino, making the small bones of a hominin child easy work. Saber-toothed cats like Dinophilis patrolled the few remaining trees. A specialized primate killer, its long canine teeth were designed to shatter the skull and puncture the brain directly, rather than suffocating the prey through the throat. On the ground, they faced the mossback lion. Twice the size of a modern king of the jungle, these 500-kilo giants hunted in groups and could reach speeds nearly 3 times faster than a human ancestor. Even water offered no safety. These rivers held giant crocodiles weighing over a ton. A single strike from their jaws delivered enough force to drag a hominin into a lethal death roll before they could even scream. For Homo habilis, the environment was a checklist of nightmares. they were the most vulnerable items on a very crowded menu. This created a desperate biological paradox. Their evolving brains required a massive amount of high-calorie protein, but their weak bodies were physically incapable of hunting. To survive, they became scavengers. They waited for the apex predators to finish a kill, then moved in to steal the leftover meat and nutrient-rich bone marrow before other scavengers could arrive. This was high-stakes teamwork. Scavenging required one group to track a carcass, another to distract dangerous predators like hyenas, and a third to quickly strip the meat and escape. A single mistake meant death for the entire group. This coordination, locating a carcass, distracting a predator, and timing a theft, required a leap in communication. This constant demand for primitive signaling left a physical footprint. Fossilized endocranial casts show Broca's area was already expanding to process these increasingly complex social cues. Human social structures and language emerged as a direct response to our physical vulnerability. We survived because we were forced to coordinate, turning a biological disadvantage into our species' defining trait. Our ancestors didn't conquer the world through strength, but through the intelligence needed to survive being weak.